Hi everyone, my name is Thomas Kim. Today is September 6, 2022. This is my 53rd episode for C++17 2023 CUDA SQL OpenGL TBB. This is also 5th episode for rotational motion. In this episode, I will discuss additivity of pulsed moments from Thomas's calculus 10th edition. If you double click this link, you can open this PDF. This PDF contains only 4 pages. Please double click this link to download this PDF file. If you double click it, you can find Thomas's Calculus 10th edition. I could not obtain PDF file for Thomas's Calculus 10th edition, so I scanned a few pages. Here, Chapter 12, Section 2, Area, Moments, and Center of Mass, page 999. If you scroll down, you can find Pappus formula. In this episode, I will explain how to derive this formula or more generalized formula. This book says it is Pappus formula, but when I googled, I cannot find such term Pappus formula. Instead, some other math book I found additivity of pulsed moments. So I titled this video Additivity of Pulsed Moments. With this formula, we can solve this problem, and many more problems very easily. By deriving this formula, you can learn something that is not explained in your math book or physics book. I have read Thomas's Calculus 14th edition about center of mass, but I could not understand. I also read 10th edition of Thomas's Calculus. I still failed to understand center of mass correctly. Then I read Fundamentals of Physics by Halliday and Lesnick about center of mass. I failed again to understand it correctly. I read Physics for Scientists and Engineers with Modern Physics about center of mass. In this book, I still failed to understand center of mass correctly. Then I read Calculus Early Transcendentals by James Stewart. I finally could understand completely what center of mass means. If I haven't read James Stewart's Calculus Early Transcendentals, it's very likely I still don't understand center of mass. Many people cheat themselves. They make believe they understand. They memorize the formula, the equations, and believe they understand. Actually, they don't. You can memorize this formula and apply it to these problems. But still, you cannot derive this formula by yourself if you do not understand center of mass correctly. If you understand center of mass correctly, then deriving this formula is just piece of cake. Now we are going to prove center of mass M1, M2, Mn over M1, C1, M2, C2, Mn, Mn, Cn. We can say total mass over sigma mi ci. We have a coordinate system. This is the origin. We have a solid object. I will label it R1. Here is another solid object. I will label it R2. Its center of mass C x1 bar. Its center of mass y1 bar. Its center of mass x2 bar. Its center of mass y2 bar. The center of mass that we are looking for is here, x bar. Now, one point here, x, y. One point here, x, y. This distance from the center, this distance is d1. This distance is d2. With respect to x bar, this dm1, this dm2 will create clockwise rotation. This point will create counterclockwise rotation with respect to this line passing through center of mass. Center of mass. So, integral R1, this R1, this weight dm1, this distance should be greater than 0. So, x bar, this x bar, x, this x, d1 should be equal to R2 dm2, this mass dm2, this distance x minus x bar. This x represent this x, a point on R1. This x represent a point on R2. X bar represent new center of mass of this system. Now we move left side to the right side, then becomes 0 minus R1 X bar minus X dm1 plus R2 X minus X bar dm2. Now we distribute -1 here. Then we have R1 X minus X bar dm1 plus R2 X minus X bar dm2. Now we distribute like this. R1 X dm1 minus R1 X bar dm1 plus R2 X dm2 minus R2 X bar dm2. Now this is x1 bar m1 minus x bar is constant. We can take it out. X bar, this is m1. This is x2 bar m2 minus x bar m2. I will explain this part. X1 is the center of mass of M1. So xdm1 from this M1 x1 bar xdm1. In the same manner, this is also true. So 0 equals x1 bar m1 plus x2 bar m2 minus this term m1 plus m2 x bar, this term and this term. So we move this term to the left. Then m1 plus m2 x bar equals these terms x1 bar m1 plus x2 bar m2. Then x bar m1 plus m2 x1 bar m1 plus x2 bar m2. In the same manner, y bar m1 plus m2 y1 bar m1 y2 bar m2. So if we generalize it, x bar total mass sigma mi xi bar y bar equals total mass sigma mi yi bar. In vector format, C is x bar I, y bar j. In vector format, C equals m over sigma mi ci, where ci equals x bar I, y bar z. This we proved.
I pledge allegiance to the violin of the united calculus of early transcendentals, and to the republic for which it stands, one science under math, indivisible, with liberty and justice for all humanity. I pledge allegiance to the violin of the united calculus of early transcendentals, and to the republic for which it stands, one science under math, indivisible, with liberty and justice for all humanity.